All right, we're going to pick up with problem 21 where you're asked to express this logarithmic expression in terms of sums and differences of logarithm. Some things to remember is that your product rule states that if you have a product of numbers that you can write that as a sum. The power rule says that if you have a power you can pull that to the front to multiply that as a factor. So in this particular one, they're all going to have the log base a. So I'm going to have the log base a of 9. There's my first factor. And then plus, since the next factor is x to the 6, I'm going to pull the 6 to the front. That'd be 6 log base a of x. And then I have y, so that'd be log base a of y. And then I have z to the 4th, so I'm going to pull the 4 to the front, 4 log base a of z. So this is what I'm looking for, and it looks to match up with A. All right, question 22. Again, writing it as sums and difference. The first two numbers will be multiplied, so I have the log. There is no base, so I don't have to write a base. The log of 5 plus, since it's x to the 6, that'd be 6 log of x. And then since I'm dividing, I'm going to have to minus 7 log y. It's not in this particular problem, but if you had been dividing more than one thing, I've seen that in problems before, you'd have to make sure both things were subtracted. So be careful about that. Anything on the top would be added, anything on the bottom would be subtracted, like this one. All right, so in this particular one, it's going to be log base b of m to the 4th, so I'm going to bring the 4 to the front, 4 log base b of m plus p to the 3rd will be 3 log base b of p, and then divided by, so I'm going to have subtract, since it's n to the 2nd, that's going to be 2 log base b of n, and also another subtract, 7 log base b of b, because I need to take that to the front. Both of these are subtracted. Looking through here, this can be simplified, so I'm going to recopy everything else. 4 log base b of m plus 3 log base b of p minus 2 log base b of n minus 7 log base b of b is 1. So 7 times 1 is 7. So my answer would be B. Number 24. All right, so here I have a cube root, which is really a 1/3 power, same thing. So I'm going to take a 1/3 to the front, and it's going to be times all of this stuff, and I'll worry about distributing it once I get everything expanded. So I'm going to have, since it's x to the 7th, that's going to be 7 log base b of x. And then minus, since it's y to the 4th, that's going to be 4 log base b of y. And also another minus 5 log base b of z. And now I'm going to distribute the 1/3 times everything. So 1/3 times 7 would make that 7/3 log base b of x minus 1/3 times 4 would be 4/3 log base b of y, and then minus 1/3 times 5 would be 5/3 log base b of z. So my answer is going to be C. Number 25 expresses a single logarithm. Okay, there's not a base, they're both logs, so I'm going to write log once. It's minus, that means it's going to be a division problem. What comes first is going to be t cubed plus 125, that's going to go on the top, and then on the bottom is going to be t plus 5. And here we've got an issue because this is going to ask us to divide, because none of these match this. This one comes close, but it's got 2 logs, and this one only has 1. So what I've got to do is I've got to divide t cubed plus 125 by t plus 5. So if you know how to factor a cube, you can do that. Otherwise, I'm going to do synthetic division. So I'm going to put a negative 5 out here to the side. This would be 1, 0, 0, 125. And it should come out to be even. Bring down the 1. Negative 5 times 1 is negative 5, and add. You get negative 5. Negative 5 times negative 5 is 25, and add. And negative 5 times 25 is negative 125. So I end up with, if I divide these two, instead of the log of t cubed plus 125 over t plus 5, it's the log of t squared minus 5t plus 25, which is A. All right, number 26. We're going to write it as a single logarithm. So this 1/2 right here would need to be the exponent. So in other words, that's going to be natural log of x to the 1/2. Or another way to write that is the natural log of the square root of x. That's the 1/2 power. And since it's subtraction, you can write it as a fraction with one natural log. So the square root of x goes on the top and 9 goes on the bottom. Natural log of the square root of x over 9, and it's D, not B, because B is the 9 should not be underneath the square root. Number 27. Again, we're combining, so it's going to be the log base B of 8x times, this would be x over y to the 4th. There's a lot going on there. So what that simplifies to be is, and the reason why that is, the 4 would go for both of these because it's in front, and since it's subtraction, that makes this a division problem. So this becomes 8x times x to the 4th on the top, and I've got a y to the 4th on the bottom, which would be log base b of 8x to the 5th on the top and y to the 4th on the bottom, which is b. All right, number 28. They give us these approximations of some common logs and want us to find the log base a of 64. So what I need to do is rewrite 64 using either 4 or 7 or a combination of the two. Well, 64 is 6 times 8, 3 times 2, 4 times 2. Really the easiest way to do that is 64 is, do 4 times something, that'd be better. 4 times 4 times 4, right? So another way of writing 64 is 4 cubed. So it becomes, take the 3 off, move it to the front, log 3 times the log base a of 4. And the log base a of 4 is 0.602. And 3 times 0.602 is 1.806. 29, these are just some common log rules. Anytime the base and what you're taking the log of are the same, they kind of cancel out. So what you would do is you take this 5 and move it to the front. I know you can't see when I write all over it. But that becomes 5 times the log base a of a, and this is 1, so 5 times 1 is 5. Your answer would just be 5. Same thing here. If you were to take this part out and bring it, rewrite it, the 3 and the log base 3 would cancel, so your answer would just be 9x. And here, e and the natural log would cancel. So what you have here is, so e natural log of x to the 42nd will just be x to the 42nd, using those rules and properties of logarithms, common logarithm rules. So e and natural log kind of cancel each other out. All right, so if I want to solve an exponential equation, the easiest way to do it, if it's set up like this, is to make them both have the same base. So here on the left, I have e to the 10 minus 2x. On the right, I have 16. Well, 16 is 2 to the 4th. So now I've written them and they have the same base. So if 2 to the 10 minus 2x equals 2 to the 4th, then 10 minus 2x will equal 4. And then solve that. You get negative 2x equals negative 6 divided by negative 2. Whoops, negative 2, x will equal 3. And you do want to make sure, this one, that's the only choice, it's got to be 3, but you do want to make sure when you plug them back in that with an equation that you go back and plug it in and make sure that it really works. And you can check it on your calculator. I'm going to pause it right here and pick up the last few.